So today we are going to do some more on graphing polynomial functions. We're going to find the zeros of a polynomial equation by factoring. We're going to graph the polynomial equation using x-intercepts and n-behavior. We're also going to use y-intercepts. We're going to identify the coordinates of a local max and min from the graph of a polynomial function. We're local max and min there. You have turning points, and when it's the high point, that's the local maximum. When it's higher than all the nearby points there. So an example of a local max down here is there at 0, 3. The local minimum is another turning point, and it's lower than the nearby points there. So 2, -3 there is considered a local min. I always think of the local max as being like little hills and the local mins as being valleys. So over here we can just kind of practice doing some of those since we haven't done those yet. So if you look up there, we have a local max up there at that hill and at 0, 3. So you name the entire ordered pair. Okay, and then the local min, and you have to tell me which one's which. And that one's over here at -3, 0. And then the next one over here, we've got a local max there. And it's there at 0, 0. Again, it's a hill. The values are your local mins. And what would those be? You've got one here, and you've got one here. So you have to identify those. So -1, -1, and another one over here is 1, -1. So we're going to factor these, we're going to graph these out, and we're going to find all the values that we need to find to do these. So the first thing you want to do is factor this. So hopefully you notice that it has a GCF in this. So if I take an x out of each of these, I get x squared minus 2x minus 3. I want to continue factoring this because I've got a quadratic over here until they're down to linears. So x times x is x squared. What multiplies to give me -3 and adds to give me -2. It'd be a -3 and a +1. So let's go ahead and name our zeros. So if you see them, you can just go ahead and name them. If you don't, then you set each of them equal to 0, and you solve for x in each of these. So here x equals 0. Here I would just add 3, and I get 3. Here I just subtract 1, and I get -1. Notice there's no squares on any of these terms in the factored form there. They're all singles there, so they don't have any multiplicity on those. So now let's go ahead and let's graph those out. So 0, and then 3, 1, 2, 3, and then a -1. So then the next part here that I want to do here is to go ahead and find the y-intercept. You can see that we've just found it. 0, 0 was already there, so I can just name it. That's both an x, so it's a 0 and a y-intercept in this case because it hits both axes. So I don't really need to solve for that one. And then let's look at the degree because we're going to look at the end behavior here, but let's find the degree. The degree is the highest power of an x in the problem, so if you look back at the original p of x there, it equals x to the third. The leading term there is x to the third, which is odd. And so it has a degree of 3, which is odd. And then the leading coefficient there is 1, which is positive. So knowing all that, let's describe the end behavior. Remember we talked about that up and up, down and down, down and up, or up and down. Since it's odd, that would be down and up. So we know a lot of pieces there, but we need to find those local max and mins. We're going to use our graphing calculator to do that. So you're going to need to get out your graphing calculator in order for you to name those. So I'm going to come down here and write out local max and local min, and let's find those. So let's go to our graphing calculator now. Pull that up. I'm in my y equals, so hit y equals and this will come up. And then let's put in our equation. So I always put in the factored form. It doesn't matter if you put that one in the original one. I just do it this way. So I put in x, parentheses, x minus 3, and then x plus 1. Hit graph. So again, down and up just like we said it would. And so I'm going to go second calc to go ahead and find those local max and mins. I'm going to find my max here first. So I need to go down to maximum. And then I can use my right arrow here, go on the left side of the point that I want, hit enter. Use my right arrow, go on the right side of the point that I want, hit enter one more time, and it'll put it there. So negative 0.535, and then 3 decimal places, and then the y there is 0.879. We're not rounding either one of those up because they're below 5 in that 4th decimal place. So let's go ahead and find the minimum while we're at it. So second calc, go down to minimum, which is minus the 3rd one there. I'm going to use my right arrow, surround that point, so I'm on the left side. I'm on the right side, hit enter one more time. It's going to put it right there. So 1.869, that 5 is going to round that 8 up. It's 5 or larger in that 4th place, going to round that 5th place up. And then the y, negative 6.06, and that 6 over there in the 4th place is going to round that 4 up to a 5, so negative 6.065. So now let's come over here and let's name those. So my local max there is negative 0.535 and 0.879. My min here, my local min, 1.869. And negative 6.065. So now let's just plot them out here on our graph here. So we already got our y-intercept, we got our zeros. So let's plot negative 5 about, and then up about 0.8 or 0.9. And then over here, 1.8, so it's a little shy of 2. And then down to negative 6. 1, 2, 3, 4, 5, 6, and a little bit more. Let's exaggerate that just a bit. So we said this is going to be down and up. So down and up here, graphing this out here. They're all singles, so they're just going to go through the points. Mine's not turned out so great. I'm a little wobbly on this. Hopefully you can do this a little bit better than I can. So there's the graph of that. So let's do another full one of those, and then I'm just going to focus on the factoring part just to remind you how to factor everything. So this one here, you just want to pull out the GCF here. I can see it's not an x squared here, it's an x to the 4, so I can see they all have x squared in common. I'm going to pull out a negative as well because that leading term there is negative. So I'm left with 2x squared. Pull out the minus, and now this is a plus x. Pull out a minus, and now this is a minus 3. So I'm going to continue factoring this. 2x times x is 2x squared. What times what gives me 3? It'd be a 3 and a 1. Middle term there is positive, so the larger product here has to be plus. So that's a 3x. That's a minus 2x, and that does add to give me a 1x, so that's good. So let's name our zeros here next. My zeros here, so I can take each term, set equals 0, and solve for x. So divide by -1, take the square root, and I get x equals 0. 2x plus 3 equals 0. If you know them, you can just name them. Subtract 3 and divide by 2. X minus 1 equals 0. Add 1. So now I can see my zeros there. I've got one here at 0. I've got one here at 1. And I've got here one at -3/2. Or -3/2, which is -1.5. So then our next thing here is to find the y-intercept. I keep giving you easy y-intercepts. So again, you see how the y-intercept already is 0, 0. Let me show you in case it doesn't end up being 0, 0 what you would do. What you want to do if it's not 0, 0, you want to let x equal 0. And plug it either into the original one there or plug it into the factored form. So however you want to do that. I usually like to do the factored form, but you don't have to. So I'm just putting 0 in for x. So I've got 0 squared is 0 times the -1 is 0. And then over here, 2 times 0 is 0, plus 3 is 3. And the last one, 0 minus 1 is -1. And so I end up just getting 0 in this case. It doesn't always happen to be 0, it just happens to be the two first examples we did here happen to be the same as your x-intercepts, which was 0, 0. All right, so then our next piece here is to go ahead and figure out the degree. So what was the highest power of an x in this? And it was a 4, which is even. And then the leading term there was negative. And so now we can determine the end behavior. Because it's even and it's negative, what do we say the graph is doing? It is going down and down on the ends. Right, so then our last piece here is to identify the local max and the local min. So my local max here, we can find them. Let's use our graphing calculator to do so. So go to your y equals there, clear out what you had in there before. You want to punch in, let's see, negative, make sure you use the negative key there, x squared, and then parentheses 2x plus 3. Again, I'm using factored form. If you like to use the original in standard form, that's fine. And then x minus 1. Hit graph. So like we said, it's going to be down and down. So now we need to find those. It looks like we've got 2 maximums there. So second calc, go down to number 4, which is your local max. I'm going to move it over here on the left side someplace, hit enter, move it on the right side of the point that I want, hit enter, enter one more time, and -1.074, that 5 is going to round that 3 up to 4, and 2.038, that 2 is not going to round it up. So there we have it for that one. Now let's go ahead and find the other one, the other local max. So that's 4. There I'm on the left side of the point that I want. someplace on the right side. Enter again. And 0.699, that 5 is going to round that 8 up to a 9. 0.647, that 8 is going to round that 6 up to a 7. And then there's one other one I want us to do, and then we're going to talk through that one. So I can calc that one in the middle of those two local maxims is the minimum. And maybe you've already identified what that is, and hopefully you have. You can tell me what this is. But I'm going to go on the left side and see what the calculator tells us what it is. The right side, enter, one more time. So, kind of to talk you through this one here, that 9.01, I'm just going to call it 9.01. I'll remember that. So 9.01, and you might have gotten something different, e to the negative 7. What that means is you're going to move the 7 places, 2, 3, 4, 5, 6, 7. So essentially you have 6 zeros. So 0.000000901. That's what that e, the negative 7, means. You have to move the decimal point that many places. Well, that is basically 0. And so your calculator sometimes will error on that and doesn't identify 0, 0 there perfectly, even though that's what that 0 there is. And we know it's 0, 0 because back at our zeros there, we know that one of them is 0, 0, and we know that's a turning point there because it bounces at 0, 0. That also ends up being our local min. So just be aware that when you come over here and you look for your local min, you do not say this is 9.012 and 2.436. No, you have to know that that ends up being 0, 0 because that's what happens when you move the decimal point over that many places. It's basically 0, 0. Just your calculator is not always that accurate. All right, so local max. Let's identify those. So we already said those, so let's just write them down. We had 2 of those. So writing those 2 down, we got a negative 1.074 and a 2.038. And our other set there is 0.699 and 0.643, 0.647. All right, so let's plot them. So -1 and a little bit more. I just kind of exaggerate them and go up to 2 and a little bit more. And then our other one there is 0.69, which is about 0.7 and up about 0.7. And then our other one there is at 0, 0. So we're supposed to be down and down. So let's do that. So we're supposed to start down, turn here on the local max, bounce here at that 0, turn here, and then come back through. So there we have that graph. So I don't think the rest of these should be any problems for you. The only thing here might be is the factoring part of it. So I want to go through some factoring part of this for you with you. So when you factor one like this, so you can pull out the GCF, which is an x squared. You're left with an x minus 2. Over here, if the leading term over here, the second part is a negative, you have to pull the negative out. So minus 4, and I'm left with x minus 2. So then these two terms have in common an x minus 2. So then you're left with x squared minus 4. I can continue factoring that x squared minus 4 because you're going to recognize that as the difference of squares. The square of the first term is x. The square of the second term there is 2. And then 1's a plus and 1's a minus. So really you have 2x minus 2, so we're going to say x minus 2 squared. And then we have an x plus 2. So that's completely factored there. So then if we were to identify the zeros here, x minus 2 there would be 2, and then it has a multiplicity of 2. And then we also just have a single negative 2. So now you would plot 2 and negative 2 and continue finding the other pieces with that. But I wanted to go through one where you actually had to go use factoring by grouping. So I want to go through some of the other ones here and just factoring with you to make sure we've got a good review and handle on factoring, because that seems to be the struggle if you're going to struggle with these. So continuing with these, noticing a GCF, yes, I notice x squared that they have in common. What's left? X squared minus 4. Noticing that difference of squares here again, so I can factor that. I have an x and an x, because the square of the first term, square of the last term. And so then what are your zeros? You've got 1 at 0 because that x squared, and then we also have, it's not only just at 0, but it has a multiplicity of 2 there because it's a squared. And then our other ones there are at negative 2 and 2. And then you could go on and find the other pieces. So then, kind like this, you'd want to factor this. There's no GCF in it, so let's just factor it. What times what gives me x to the 4th? X squared. What multiplies to give me 1 adds to give me a negative 1. Or, sorry, adds to give me a negative 2. That would be a minus 1 and a minus 1. I can continue factoring that x squared minus 1. I'm going to have to do it down here. So x squared minus 1, square of the first term is x. Square root of 1 is 1. 1's a plus, 1's a minus. Square root of x squared is x. Square root of 1 is 1. 1's a plus, 1's a minus. So that means I've got 2x plus 1's. It means I have 2x minus 1's. So what does that mean? Well, for zeros, how do you get 0 at x plus 1 when x is equal to negative 1? And it has a multiplicity of 2. Oops. So let's call that a multiplicity of 2. And then our other one there is x equals 1, and it also has a multiplicity of 2. So don't forget it's going to bounce at those spots. And they could be local mins and maxes as well. So let's look here at example 7. So again, let's factor this. What times what gives me x to the 6th? It'd be x to the 3rd and x to the 3rd, because remember you add the powers. 3 plus 3 is 6. What multiplies to give me negative 5 and adds to give me 4? That would be a positive 5 and a minus 1. So then you could continue on with those. So just showing you how to factor that out. So these are your learning targets. You can find the zeros, I can graph, and I can identify the local mins and maxes.